Good morning, everybody. Welcome back to Calc 1, the last non-exam day of Calc 1. Plan for today is I do have a quiz for you on the first half of Standard 21, and then we will finish Standard 21 off by talking about how to do definite integrals on using the substitution method. Usual office hours today at 11 and at 2. Tomorrow at 10 and 1. Tomorrow morning I have to cut my morning office hour 15 minutes short because we have a faculty meeting I have to get over to at 11. As far as homework goes, not assigning any new homework. Don't forget that last midterm is on Friday, final exam on Monday at 8 a.m. Bright and early. Also web work due Friday. Just as a reminder, for both exams, you are allowed 2 sheets of notes, front and back, whatever you want written on it. If you go in, I have updated Canvas with everyone's mastery totals up to yesterday. So you should be able to go in and see exactly which standards you still need masteries in. I'll also try to get these quizzes graded by tomorrow morning, so and post those scores so you can see what those are as well. Yeah, any questions or comments before we get started for today? Why did the geometer make a giant mess in their oven? It's because the instructions said to put in the food at 180 degrees. And with that, we're going to go ahead and get started with the final quiz.
That's what we're grinding at. We basically have 2 full days to work. Finishing it off. We proved it, now we'll use it. Exactly.
Go ahead and take a few seconds to finish up your thoughts. And pass your quizzes in, please. No, I spoke over here this time.
What was your comment? What was the U supposed to be? You were supposed to be like that. Sure.
I just rewrote.
Oh, 2x.
Okie dokie. So, class on Monday, we focused on how to evaluate indefinite integrals using the substitution method, where we make a new variable u, which we set equal to some expression in terms of x, and then make it so that if we rewrite our entire integral in terms of u, it becomes a lot easier to solve than writing it in terms of x. So what I want to focus on today is how to do the same process with definite integrals. So I'm going to be on the page of the packet that at the top starts with evaluate the following definite integrals. And specifically, I'm going to look at the integral from 0 to 1 of x divided by x squared plus 1. So to me, this doesn't look like the integral of any function that's particularly friendly. So I think we're going to have to use the substitution method. And doing substitution with a definite integral ends up being pretty similar to how you would do substitution using an indefinite integral instead. There's just a slight tweak to it that makes it so there's a couple of methods you can end up using in order to get to an answer in the end, which is what is the area underneath this curve, x over x squared plus 1, from x equals 0 to x equals 1. So to start with, we're going to do the same thing we did with the indefinite integrals. We're going to let u be equal to something in a way that will make our problem a little bit easier to work with. Does anybody have an idea for what a good choice of u might be in this one if we wanted to integrate x divided by x squared plus 1? When?
X squared plus 1.
Try letting u be x squared plus 1? Okay. So if we do that one, what's our du dx going to be?
It's going to be 2x dx. Or sorry, 2x. Sorry.
It's going to be 2x, and then du will be 2x dx.
And then divide both sides by 2.
Since we have an x dx and not a 2x dx, we can divide both sides of this expression by 2. Tell us that we can replace our x dx up here in the numerator with a 1/2 du. I like it. Yeah, so if this is an indefinite integral, from here we would just plug in and get something like 1/2 times 1 over u, integrate that, get 1/2 natural log absolute value of u or something. Here though we have a definite integral, and so we have these kind of two boundaries, these two values of x that we have to keep track of. And there's going to be sort of two different approaches we can take to handling our boundary values of 0 and 1 that make this a definite integral as opposed to an indefinite integral. And so the first method, I'm going to introduce both to you, and then you're just going to be able to pick which one you want. The first method is going to be to rewrite the boundary values, so the 0 and 1 here, in terms of the variable u instead of in terms of x. So if we start with x equals 1, what do we get? If x is equal to 1, what would u be equal to? Meaning, we have a way to write u in terms of x. U is always just going to be equal to x squared plus 1. So if we're looking at a value of x equal to 1, what would the value of u be at that point? That?
2.
How'd you get that?
X squared, you plug in the 1 for x squared, you get 1 plus 1 equals 2.
Yeah, if x equals 1, we can just plug 1 into this equation to solve for u, and we'll get u is going to be 1 squared plus 1 is equal to 2 at this point. And similarly, if we look at our other boundary value here, at x equals 0, what would our u value for x equals 0 come out to? Right? Well, if we plug in u equals 0 squared plus 1, it is indeed going to come out to 1. And so the approach we can then take is we can say that when we rewrite our whole integral, x over x squared plus 1, from x equals 0 to x equals 1, in terms of the variable u, we have x dx over x squared plus 1 is going to be 1/2 times 1 over u du. In the same way that we did yesterday in our indefinite integrals. X dx becomes 1/2 du, and since we're dividing by x squared plus 1, that'll be the same as 1 over u du. Except instead of plugging in 0 and 1 as our boundary values, we're going to plug in the u values that we found instead. So in place of x equals 0, we're going to plug in u equals 1. And instead of x equals 1, we can plug in our u value at that point of 2. And just to be clear, the 1 and the 2 are going to be values of u here, whereas the 0 and the 1 back here are values of x instead. In changing our integral to be an integral in terms of a new variable u, we not only have to take the x dx divided by x squared plus 1 stuff and write that in terms of u, we're also taking the values we're integrating between and writing those in terms of u as well. So let's integrate this now. So if we use the fundamental theorem of calculus, that's going to tell us as long as we can take an antiderivative of 1/2 times 1 over u with respect to u, then we can plug in our u values, 1 and 2, in order to get a numerical value for our final answer. What would we get if we wanted to find an antiderivative of 1/2 times 1 over u? Zach?
1/2 times natural log of absolute value u.
Yeah, exactly. Integral of 1 over u is natural log of absolute value of u, and then the 1/2 out in front just gets carried along for the ride. And the nifty thing here is that since 1 and 2 are values of u, and we have some expression in terms of u, according to the fundamental theorem of calculus, you can just plug in these u values in for u here to get 1/2 natural log of absolute value of 2 minus 1/2 natural log absolute value of 1. Because that's what the fundamental theorem of calculus says for integrating. For doing a definite integral is find an antiderivative, plug in your endpoints, and subtract. Yes, I do.
So do we not need to rewrite it in terms of x?
Nope, because our boundary values 1 and 2 here are in terms of u. When we get to method 2 here in a minute, we are going to have to do it that way, but for this method, since everything is already in terms of u, we can just plug in our u values here into this u expression. If we convert it back in terms of x, then it wouldn't make sense to plug in u values into an expression that's meant for x, the variable x instead. Here the absolute value ends up not mattering, because absolute value of 2 is just 2, absolute value of 1 is just 1. Natural log of 2 is not a nice number. Natural log of 1 is a nice number. You know what the natural log of 1 is. In other words, what power, e to what power is going to give us an output of 1?
0.
Yeah, so natural log of 1 just turns out to be 0. So this term goes away. Our final answer is going to end up being 1/2 natural log of 2. So that with this method, we converted everything in our integral to be in terms of the variable u, including our boundary values, so that when we take an antiderivative, we could just plug in those u values and subtract to get our final answer. Any questions or comments about what went on here? Yes, Emily?
Where did you get 1 over u?
Here you mean?
Yeah.
So basically here with the x divided by x squared plus 1 dx, we can actually write that as the integral of 1 over x squared plus 1 times x dx. And then since u was x squared plus 1, 1 over x squared plus 1 would just come out to 1 over u. Does that make sense? And then the x dx became the 1/2 du stuff. So let's look at the second method, which is going to be pretty similar, but has a slight tweak to it. So our second method is, instead of writing the boundary values in terms of u, what we're going to do is something more akin to what Rachel suggested earlier. We're going to leave our boundary values in terms of the variable x, then convert everything back to x in the end. So everything's the same up to this point, where we've chosen u equals x squared plus 1, du will give us 2x dx, so 1/2 du will give us x dx in method 2. Everything's going to be the same up to there. The difference is going to be when we write our 1/2 times 1 over u du terms, replacing the x dx with 1/2 du and the 1 over x squared plus 1 with a 1 over u. We're going to do something a little bit different here. And instead of trying to convert our x boundaries, x equals 0 and x equals 1, to be in terms of u, we're just going to leave them as x values for now. And so I'm explicitly going to write out x equals 0 to x equals 1 to denote the fact that though the expression we're integrating is in terms of u, our boundary values are still values of x for now. So with that, we can integrate the same way as before to get 1/2 natural log absolute value of u from x equals 0 to x equals 1. And now we can't just plug in 0 and 1 for u, because 0 and 1 are not u values, they're x values. So here, Rachel, I think we're going to have to do what you were suggesting we do earlier, which is now we can convert our u expression to be back in terms of x instead, which would give us 1/2 natural log of absolute value of x squared plus 1, evaluated from 0 to 1. And here, once everything's back in terms of x, we don't have to keep writing out x equals 0 to x equals 1. Because if we don't write anything otherwise like this, we're just assuming 0 and 1 are values of the same variable that's in this expression here. And now we can just plug in 1 and 0 normally for x, which will give us 1/2 natural log of 1 squared plus 1 minus 1/2 natural log of 0 squared plus 1. Plugging in our boundary values for x here. And I think we'll still end up with 1/2 natural log of 2 minus 1/2 natural log of 1. And just as before, 1/2 natural log of 1 is just 0. So we get the same answer either way. So the key difference here is that in the first method, we won't rewrite everything in terms of u, including our boundary values. 0 and 1, which are x values, get converted to u values. And then when we get to this step, since our boundary values are already in terms of u, we can just plug them into the u expression to end up with 1/2 natural log of 2. Whereas over here, we never convert our boundary values to u values. Instead, once we integrate with respect to u, we just rewrite in terms of x. And once we've rewritten in terms of x, then we can just plug in our x values and end up with the same thing. Dr. Gerstel, are you ever going to ask us to do both of these methods? Or have to choose one or the other? Nope. I personally don't care which of these methods you use if I give you a substitution definite integral problem. I recommend you pick one and stick with it. Because no matter which method you use, you're always going to get the same answer in the end either way. Any questions or comments about either of these methods? Out of curiosity, by a show of hands, who prefers method 1 out of these two methods? It's a good chunk of the class. Who prefers method 2? A smaller chunk of the class. Personally, I prefer method 2. So if you see me like write stuff up on the board and such, you'll probably see me do method 2 from now on. But it doesn't matter to me which one you all do. Pick whichever I think. I think you should just pick whichever one feels comfortable to you and then stick with it. Because I'm never going to make you do both, or I'm never going to specifically say do one or the other. I'll just say here's definite integral. Evaluate it for me. All right. So with that, I figure I'd give you all a few minutes to work on a couple of integrals yourselves. So on the next page of the packet, we have, oh my goodness. Got a couple integrals. Integral from 1 to e of natural log of x divided by x. And the integral from 0 to 1 of t plus 1 times t squared plus 2t, all raised to the 5th power. And what I would like for you all to do is to take a couple minutes, and you're welcome to work with your neighbors, work with the people sitting around you. See if you can evaluate these two integrals. After you've all had a chance to look at it for a couple minutes, we'll come back together and talk about it as a class.
What'd you say?
The derivative of 1 over x is natural log.
I don't know.
Sounds like, I think you went the other way around.
Oh.
Your U is L.
Say the derivative of natural log is 1 over x, but not vice versa. If you're ever unsure about it, try using the chain rule to take the derivative of what you end up with, see if you get what you start with. Okay. Hey, it's definitely a tricky one to deal with. Well, I think you have two choices here for what your u could be. You want your u to either be just natural log of x or clean.
Yeah, you're right. I'm stupid. Why does that go
So something to think about is, are either of those the derivative of the other one?
Where's that? Oh, because it's 1 over x divided by.
What's the derivative of natural log of x?
Right.
I might not be. It's just you. And then you have to take the integral.
That's right.
1/2.
Yeah, you basically have natural log of x.
1/2.
So why don't you try learning how to use the natural log of x
Am I doing it all wrong?
and see what happens in there.
So that you make it x. For x, you make your u x. Yeah, ln. So it's definite y. Because then when you take du of dx, it's just 1 over x.
Is it
You have 1 over x as well. Because
Oh, because then you just change x and put 1.
Sorry, I gotta test out this class repetition.
Because really that's natural log of x.
Yeah.
You said your u.
Yeah, but I did that the same way.
You'll plug in things.
Yeah. I feel like this is.
Up to you which method you want to
And
use.
then it's equals. Because then, so when you divide it, you're not dividing it. Oh, no, no.
So
So
you
it's
just.
just split that into ln of x plus
Yeah.
1 over x.
We did it. Yeah, that went so well, guys. This one.
I don't like that.
The
next one was
after the second.
This is just.
I need a safe space.
But a few extras. Does anyone need a copy of the practice?
So I think you Yeah.
Yeah, it's just like.
Great.
No, it's just, just you.
I knew that you did this all the time.
I don't know
Yeah,
how
I'm
to
like,
do that.
no.
That's 1 over x.
How about today? Yeah. Oh, yeah, because I was thinking I have to put it. And sometimes.
Any questions over here?
Yeah.
Is that correct?
Let's see. If you convert from integral of u is certain half u squared, and then
This one.
I like it.
This does nothing for me.
Oh, wait, I can
take
out
a 2.
That does nothing for you. Oh, all right, sorry. Well, now I have to come investigate this.
No, I just
I
need
got,
to take out a 2, and then it'll.
And then things will work for you.
Actually, I don't actually know if that's true.
Well,
I think about
1 half.
I think if you divide both sides by 2, your life will become easier.
0 to the power of 0. Okay. Or not bad.
I was gonna say, yeah, t, but yeah, it looks like I think it's gonna replace the t plus 1 and the t term with 1/2.
I didn't do it.
And you'll have something like u to the 5th that you're multiplying it all by.
Okay. Oh, to the 5th. That's very true.
Quite.
I do that.
Wait, I did this wrong.
Not sure how to get started on the next one.
Oh, no, I haven't even.
That's it. And sometimes you just gotta start trying to plug in a few different things for you and see what sticks. See what sticks.
1 half. Because this is just turn it
To the 6th.
no, it should be.
I've written 3 to the 6th out for you on the sideboard if that helps. Because I know that's a big number.
Wait, let's try this again. Why are we doing the 6th?
Okay. This is.
Over 6. Oh. That's for this one.
I don't think you need that for that.
Okay,
I think this one might end up.
Over
Yeah,
6.
we don't like it.
Where'd you get, Joe?
Although I know I can simplify natural logarithm.
Okay, so then that goes to
Basically saying, so what power
So what?
You're saying it was like.
that tells us that
Either
natural
1/2.
logarithm is.
Okay.
Either 1/2 to you.
Was it 7?
Where's your 1/2 to you?
29 over.
In the front.
And then the 3 to the 6th one
Because you have u
might be
equals-
might be more helpful for the bottom one.
du equals 2t, so you have to divide that by 2. So you have to have 1/2.
Oh, I forgot the
These
one
aren't good
half.
math.
Oh, yeah, so then I would just.
Can't forget the 1/2.
7 I can't read it.
No,
Wear
we're-
your glasses too.
Sixth.
That's all I know is.
long vision.
You're
getting
it. Let's do some long vision.
Wait, so what did you get for answer?
Why would we do that?
Because it's smaller, if you want something smaller, or you could leave it like that.
Oh, no, so I.
Oh, yeah.
That's a great. You just swear at the end.
You got 1/2 of yours.
If you finish the 2 on this page, go ahead and take a look at the next page while we take a couple more minutes for everyone else to have a chance to take a look.
Math. You do that. What is the derivative of like these objects, or what is the integral?
7 upon under 1.
Okay.
Good job.
So you don't. So you it's technically the one.
Five.
So you add one.
What? He said look at the other page. Follow instructions.
Yeah, follow instructions.
Exactly, that's
Exactly.
I'm not good at this.
Can't visually. I'm not good at that.
You're not good at doing anything anymore?
No, when you get in the class. My master's you off.
Sorry. Sorry to say.
I have.
And do you?
But I'll get 2 from the homework, so I guess maybe.
I
had 0 homework.
If you want to disappoint me, you have to do something like morally wrong, not
So I
like have trouble understanding calculus.
have 7.
She's from
Twice.
Nebraska, that's probably
9.
wrong.
You have to do
Okay,
7
that
twice or
would be
8.
more of a morally wrong.
I could not figure out.
Nebraska's the best. Why are we going
Yeah,
there?
why?
Then twice.
Sorry.
Because I messed it up.
The
Sorry.
best flyover state.
Twice. 4.
Okay, it's a good flyover state, I'll give it that.
Don't go to Nebraska. If you're gonna.
Sorry, I went to grad school in Iowa, I have to eat out of
No,
Nebraska.
no.
16
I was back.
17.
Where did you go?
19.
Idiot.
University of Iowa,
Oh, okay, okay.
And then.
Still not good, but that's fine. Did it once.
better than Iowa State.
Yes.
I don't know
But I
if I
agree.
got that one.
Gotcha.
You did?
You
didn't. 4 out of
7.
Yeah, but it's just like always.
Yeah, so you had to do, you multiply it by 2.5.
Okay.
So it would be,
That's what I thought you had to do, and I didn't.
so the integral would have resolved
Maybe a
it.
nail. When did you
That would
say
be
that?
Yeah, but you're good at this part.
But then the X out front gives you
Yeah, I didn't
something.
do that.
And the bottom one
Make
was
that
just
bad boy.
By solving
natural
for
log
X.
Solve
of
for you
the
get
thing.
x equals
1/2 natural log of
1/5
the thing.
times u minus 1.
We'll talk about
Plug
it
that
again.
bad
Okay,
boy in
I'll do that.
and then you do the square root of u.
That one's
No,
definitely
I
a
got
challenging one I put on the back page for a reason.
Okay.
I think that's right. Because if you take the derivative of that,
It's all
it'd
for
be
You don't know
x, because then you can put
Clearly,
it
it's
in
43 over
x
4
for u,
times
or u, whatever.
4x
I'm
times 2.5.
Okay.
2x squared times 2x.
I'll just retest it.
I'm taking the
Good for math.
test today that we're retesting again later.
Was what?
I'm taking the quiz at 11 and then at 2 o'clock, because I want to retest at 8. So I cannot understand the 8, but figure it out. All you need to do is,
Are you taking the exam today?
yep, I'm retesting at 2.
And then retesting it too. Oh, okay.
No, no.
Goodness, you get a lot, I got a lot to grade for you coming in today.
Oh, you're taking exam
Is that
today?
true?
Yeah. Because I don't, I mean, I was trying to do it anytime else.
It's the same
You
power.
have a game on Friday?
It's okay, it's okay, you motivated me to get the exam, your exam done early so I can move on to writing final exams for all my classes now.
I got you.
Math.
Otherwise I may have procrastinated and then gotten really stressed out on, tomorrow.
I thought you guys were done.
No, so we leave tomorrow at 1.
All right, let's take about 1 more minute and then we'll come back together as a class.
Hobart, Indiana. We have to do a bunch of like.
I forgot to write
volunteer
it.
stuff.
Oh,
It is.
natural log in 1 over x,
Oh,
oh goodness.
I don't get it every single time.
I don't know.
Hey, you can take it out. It's a little thing where you should.
What did you get for this first? Is that what you got for the answer to the first one? No, for the quiz.
Oh, no, I didn't even try that. I know. I wrote u, du over dx. I completely didn't know how to do that. When I saw something, I'm like, oh, I guess that kind of makes sense. You didn't do anything with e yesterday.
First of all, I think it's DDT instead of a dx, everything.
It's pretty simple.
Oh, what's the end?
Second of all, I think if you go ahead and divide both sides by 2, you get something like,
Yeah.
1/2 equals, equals 1.
Yeah, teacher.
Tope, when are y'all done with football?
I think from there, you can still go ahead and multiply both
I forgot
sides.
plus C, I forget plus C every time.
Yes,
When are you done?
1/2.
Saturday,
Last month?
yeah,
It was like last week.
and then Sunday,
I did them up until I had COVID, and then when I had COVID, I didn't
need
do
to
any.
do, I need to do the next test.
That's just a multiple. So if you're multiplying essentially both sides
Two
by
exams
two.
on Monday. And one's my ecology
You
exam,
don't
which
have,
is
if this was addition.
Hopefully they can get all the masters through
Issues.
the 17th through
You have
21.
another.
Then I have to do 8, 16, 15, or maybe just 15 and 16, because I'm trying to retest 8 for or
so you have your 1/5.
if I get 2 masters on 8, that'll be chill.
Yeah, that's what the 1/5 is, Goose.
Oh, that's just my hand.
Sure.
Sure.
Alrighty, let's come back together. Silly goose. Let's come back together for a couple minutes here, and let's do one of these. I'm gonna do one of these two integrals. Think about which one you would rather see more. Who would rather have the class work out this first integral here? How about the second integral? Second integral it is.
I don't do integrals.
Sorry to the three of you who voted on the. All right. So let's evaluate the integral from 0 to 1 of t plus 1 times t squared plus 2t all to the 5th power. Good golly, Miss Molly. So, anybody have a U for this one that they found to be helpful? All right, that's
2 squared plus 2t.
t squared plus 2t, the stuff we're taking to the 5th power. Sounds reasonable. In general, a good thing to try for you if you have a lot of different expressions going on is the innermost function. So in this case, the innermost meaning we're taking that to the 5th power and then we're multiplying by something else. U equals t squared plus 2t is kind of what my eye was drawn to as well. All right, so what would du dt be here? And does it?
2t plus 2.
2t plus 2 according to the power rule, which means du is going to be 2t plus 2 dt. Gadzooks, we don't have 2t plus 2 dt, we have a t plus 1 dt.
Divided by 2.
Ooh, divide both sides by 2. What will that give us? T plus 1 dt, because 2t plus 2 over 2 is just going to come out to t plus 1. We divide 2t by 2 and 2 by 2. I just said the word 2 a lot of times in a row there. Sort of like how I don't know, I love phrases where, this is an aside, I love phrases where you basically say the same word multiple times. Like, one of the first sentences I learned how to say when I was taking Chinese is, mama, 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 which is, did mom scold the horse? Anyways, let's go to this. Pick one. Emily, since you asked for it so kindly, you want to do method 1 or method 2 on this?
Method 2.
Method 2? All right, that's the one I did in my notes. All right, so method 2, we leave our t values as is. So we're going to write from t equals 0 to t equals 1. And then, let's see, our t plus 1 dt, we can replace with a 1/2 du. And t squared plus 2t to the 5th, I think we can replace with a u to the 5th. So what I think we'll end up with is a 1/2 u to the 5th du. Where here, since 0 and 1 are t values, I'm making sure to write in t equals 0 to t equals 1. Because if we just did 0 to 1, 1/2 u to the 5th du, then that would be essentially saying that these are u values, which they are not. Kinsey, how would we integrate 1/2 u to the 5th with respect to u?
Just leave 1/2 out because it's a constant. And then u to the 6th over 6.
U to the 6th over 6? I like it. From t equals 0 to t equals 1. So what do y'all think? Can we just go ahead and plug in 0 and 1 here for you? No. Why not?
Because that's u, and those are the t equals 1 and t equals 0 are for x.
For x?
Yeah.
You mean t?
T, sorry. For t.
I know. Changing up the variable on you makes is rather rude of me. Yeah, these are t values. We can't plug them in for u, which is why it's important to keep writing out t equals 0, t equals 1, so we don't accidentally forget and try and plug those in for u. So if we rewrite everything in terms of t, I'm going to go ahead and combine the 1/2 and the divide by 6 to get 1/12 out in front. Let's see, u was t squared plus 2t, so I'll have t squared plus 2t raised to the 6th from 0 to 1. And now that we're back in terms of t, we don't have to keep writing out t equals 0, t equals 1. We can just write out 0 and 1 since these are the same for the same variable as that expression. If we plug that in, we'll get 1/12 times 1 squared plus 2 times 1 to the 6th minus 1/12 times, and it's just going to be 0 to the 6th. And who cares about that? Which I think will give us 1/12 times 3 to the 6th. 3 to the 6th is 3, 9, 27, 81, 243, 729. So we'll get 729 over 12, which, as everyone knows, except for me apparently, it's going to be 243 over 5. I'm sorry, that was embarrassing. Of course, if this was like if this had been like a quiz or an exam question, you're totally fine to stop at that point. If you had done this using method 1, you could have said something like, oh, t equals 1 becomes u equals 1 squared plus 2 times 1 is 3. T equals 0 becomes 0 squared plus 2t is still 0. And then at this step, you could have just plugged in 3 and 0 for u, and you would have gotten to the same answer in the end either way. Again, doesn't matter which method you use. As long as you get to the correct answer, right answers are always right. Awesome. Any questions before we move on and look at a spicy one? Okay, let's go on to the next page. And I want to look at this integral here at the top, where something fun is going to happen. This time we're just going to do another indefinite integral. So no need to worry about method 1 or method 2. I want to evaluate the integral of x times square root of 5x plus 1. it's going to be another u sub. So, anybody have any ideas for what they would like our u to be? When?
5x plus 1.
All right, we're going to let u be equal to 5x plus 1, which means du dx will be 5. So du will be 5 dx. I don't see a 5, so I'm going to just divide both sides by 5 to get 1/5 du equals dx. And so square root of 5x plus 1 will become square root of u. Dx will become a 1/5 du. And we can clearly write this as x square root of u times 1/5 du. Avery, why are you baring your teeth at me?
Because there's x's and u's together.
There's x's and u's together. Yeah, I don't think we can really integrate this. Because right now we have multiple variables. We still have a pesky x in here. I already told you the answer. Danielle?
You can use your u equals 5x plus 1 and solve for x, and then plug that in.
Ooh, okay. So you want to take this, solve it for x, and then replace the x here with some whatever u expression we end up getting? Let's try that. All right, Danielle, how would you solve u equals 5x plus 1 for x?
Well, I'd subtract the 1.
Okay, so that would give us 5x equals u minus 1.
And I would divide by 5.
Like that. Okay, so Danielle's proposed something interesting. She's proposed that if u equals 5x plus 1, that's an equation we should be able to solve. That gives us a way to write u in terms of x, but we could also rewrite it as to find out how to write x in terms of u instead. And so then if we rewrite out this integral, it'll come out to u minus 1 over 5 times square root of u times 1/5 du. And now everything is peachy. Well, I don't know about peachy. Everything is pear-y, because now everything's in terms of our new variable u. Whether this is any easier to integrate than the original x expression is maybe debatable. Let's see.
There you go.
Is that a hand, Josh, or
I'm just chewing my toenails.
Alright, I see a 1/5 and a 1/5. I'm going to combine those to make a 1/25 times the expression u minus 1, and then I'm just going to rewrite this as u to the 1/2. So square root of u I just replace with u to the 1/2, and then I combine this 1/5 factor and that 1/5 factor to get a single factor of 1 over 25. We can distribute this, which is going to give us 1/25 times u times u to the 1/2, u to the 3/2, minus a u to the 1/2, which will give us integral of 1/25 u to the 3/2 minus 1/25 u to the 1/2. And now, I think we're finally at a point where we're ready to actually integrate and find an antiderivative. So it took us a little bit of algebra to get there. How are we going to integrate 1/25 u to the 3/2? The answer is carefully. So we're going to integrate it. See Wynn smirking back there. So, Wynn, how would you integrate 1/25th u to the 3/2 power?
Well, the 1/25th is a constant, so you can just keep it as 1/25 times 1/25 times u to, or sorry, 2u to the 5/2 over 5.
So you'll get, so if you add 1 to the exponent, you'll get u to the 5/2 divided by 5/2, and then we'll write that in the next step as 2/5 times u to the 5/2. So reverse power rule on u to the 3/2. If we add 1 to our exponent, we'll get u to the 5/2, and then have to divide by it. Cecilia, how about integrating u to the 1/2 power?
So the 1/25th is pulled out, so you would do u to the 3/2 divided by 3/2.
I like it. U to the 3/2 divided by 3/2. So our indefinite integral comes out to 1/25th u to the 5/2 divided by 5/2 minus 1/25th u to the 3/2 divided by 3/2. Plus constant, because it's an indefinite integral. Dividing by 5/2 is the same as multiplying by 2/5. Dividing by 3/2 is the same as multiplying by 2/3. And then if we multiply this out, we'll get good gravy, 2 over 125 u to the 5/2 minus 2 over 75 u to the 3/2. And what's the last thing we need to do before we can call this problem done? Avery?
Can you subtract? No.
If your answer is, I want to factor out a u to the 3/2, my answer is going to be, do I have to? I think there's only one thing left we still kind of really need to do before we can say we're done. Yeah?
Substitute the x's back in.
Yeah, since our original integral was in terms of x, we should have our final answer in terms of x as well. Which will give us 2 1/25ths, u to the 5x times 5x plus 1 to the 5/2 minus 2 75ths times 5x plus 1 raised to the 3/2 plus Nido Doritos. Okay, I got something I want to say. This is the last kind of standard day of class of the semester. I want to say, it's had a lot of fun teaching this class. You've all been a great group to work with. Thanks for making this a fun semester for me. I will get these quizzes graded on the exam and the final. I'm not going to give you one like this where you have to do some tricky stuff with solving for x in terms of u. I wanted you to see an example of it because it's fun and cool. But for the exam questions, you should be prepared to do an indefinite or a definite integral using substitution. But not one like this where you have this x in terms of u at the end showing up. All right, thank y'all for a good semester. I'll see y'all on Friday for midterm number 3.